I'll start directly with the help of coding. I will try to explain what is the difference between the packed and unpacked arrays. So I'll create a module called test, and first we will start with the explanation of unpacked arrays. So these unpacked arrays are similar to the arrays which are present in Verilog and C language. Uh, so I will take some example for unpacked arrays. Say int a of 5. So this is an array of 5 locations of in data type. So this is an unpacked array. So this is an unpacked array of 5 locations. So we can display this array also if needed. Initial begin. um, so I will first assign some values to this array. So I'll take 1 4 2 3 and 5. So 1 2 3 4 5, and I will display this array. The value of is percentage p comma e, and ending the module. So this is an unpacked array. So unpacked arrays are nothing. Unpacked arrays are similar to the arrays which are present in our C language and Verilog, and this is a one-dimensional array. So up to here, about the unpacked arrays, it is clear, right? Wait a minute. It is getting loaded. Yeah, run all. Uh, Wait a minute. It is getting loaded. Uh, I will reset the layout. Yeah. So at the output, we can see the contents of the array. This is a normal unpacked array where at location 0 we have data 1, at location 1 4 and 2 3 5. So this is like a normal array. Unpacked arrays are like normal arrays. We can declare them and we can use them. So this is clear, right, about unpacked array. Also we can declare let me comment this. Also we can have unpacked arrays of any width, like 2 down to 0, a of 4 locations, or we can also have unpacked arrays of bit type, say 1 down to 0, a of 3, like this. So these are all unpacked arrays of different data types and sizes. And unpacked arrays can also be used with bit data type, and we can also have byte data type, and we can also have logic and byte and int, so on. So we can declare unpacked arrays of this type, and we can also have one more dimension, 2D dimension. So this is a 2D unpacked array. Like this we can declare 2D dimension or 3 dimension unpacked arrays. So this is about unpacked arrays. Now coming to packed arrays. So if we want to use a packed array, then then the syntax for the packed array is data type followed by size of the array, that is number of locations, followed by name of the array. So this is a packed array. So this is a 1D array. And if we want a 2D array, then first we want to mention the number of locations followed by the width of each location and the name of the array. Let's say b underscore packed. So this is a 2D array. So first of all, let me add some content into this arrays, and let us talk the need of this unpacked array. So remember the syntax for packed arrays. So the syntax for packed array is clear, right? So this is a syntax for packed array. Here the dimensions are mentioned before the array name. So this is a packed array. So let me add some contents to this packed array. Let us take 7-bit, and here also 7-bit, and I will take one byte variable, say c underscore unpacked. So byte is unpacked, sorry, not unpacked. I'll take one variable as c, byte c. um, okay. So I will assign a underscore packed to a value of 8 tick binary 00101111, and I will display this. The value of a underscore packed is percentage b, comma a underscore packed. And let me compile this and simulate it. Wait a minute, I think I've done a mistake here. In the simulation, wait a minute, I have written some spelling mistake here. It is packed. Yeah, we'll compile it. A underscore packed. Near 24. Sorry, yeah, I missed a semicolon. We compile it. Undefined variable. Okay, I'll comment this since I have changed the names, so it's not. Yeah, so let me simulate it. So see here in the transcript, we are getting the value as 4 ones followed by 0010. So I'm displaying a packed array like this. So this is a procedure and the syntax for declaration of a packed array and displaying a packed array. Here I have declared a packed array, bit 7 down to 0, a underscore packed. If the dimensions are mentioned before the array name, then it is a packed array. Whereas if the dimensions are mentioned after the array name, then it is an unpacked array. So here I have mentioned the dimensions before the array name, and I am assigning the value. Here 7 down to 0 means 8 bits. So I am assigning the value to the packed array. So now we'll see a case why we are using this packed array. Wait a minute, I will take a slide and I will try to explain it. So okay, I'll take a slide here. So I'll take an example here for understanding the use case of this packed array. Why we are going to packed arrays? Generally, we don't use this packed arrays, but I will explain why we are using it. So let's say we have a byte A. So A can store 8 values. So A can, for example, A can have 1 0 1 1 followed by 4 zeros. So if we declare a variable A of type byte, then A can store 8 values. Okay. So if we want to access any particular location, say this bit, then we can access by using a for loop for I is equal to 0, I less than 9, I plus plus, a of I is equal to some output. So when I is equal to 3, or else we can write I is equal to 4, uh, we can take when I is equal to 3, then we will get, we want 0, 1, 2. So I less than 3, then we want second location, right? So A of 2 will be equal to output. Then we will get the second location. So if we want to access the second location, this is the process. We will take a for loop and we'll access the location. Or else if we want to simply access LSB, then we will declare A of 0 is equal to our output. Sorry, output is equal to A of 0. Or if we want to access our MSB, so this is for LSB, and if we want to access our MSB, then we will take A of uh, 7. This is for accessing MSB. So is this clear? If we want to access any particular bit, this is the process we are following. This is clear?
Yes.
So in case of packed arrays, I will consider a packed array. Say bit 7 down to 0, A. So this is a packed array. So A can also store 10110, 3 zeros. So it is storing this value. So in case of packed array, what can I do? Do is I can access individual elements like A of 0. I can directly access A of 0, A of 5, A of 6. A of 5 means 0, 1, 2, 3, 4, 5. So I can directly access this location A of. So I can access directly this location, fifth location, or else if I want to access this 0, 1, 2, 3, third location, then I can directly access A of 3. So with the help of packed arrays, what I am able to achieve is I can access any particular individual from this packed array. Like I can access A of 2, A of 3, A of 4. Whereas in normal case, I cannot access directly. I should use a for loop. I should extract every bit and then I can access that individual location. For example, if I have another packed array, say uh, So this 8 bit, what I'm doing is I will take two locations, and in each location I will take 4 bits. So I will basically consider a two-dimensional packed array. In case of two-dimensional packed array, I will take this example: bit 1 down to 0, 3 down to 0, A. So this is number of locations, and this one indicates number of bits in each location, and this is the array name. So this is the number of locations, this is the number of bits in each location, and this is the array name. For example, here in case of 2D array, our packed array looks like this. So there will be two locations. This is location number 1 and this is location number 2. And in location number 1, we will have 4 bits. This is bit 1, 2, 3, 4. This is first bit, second bit, third bit, and fourth bit. Similarly, in location 2, we will have 4 bits: 1, 2, 3, 4. So this is the meaning of this packed array syntax in two-dimensional. So 1 down to 0 represents number of locations, that is 2 locations, and 3 down to 0 represents number of bits in each location. So here in location 1 we will have 4 bits, and in location 2 we will have 4 bits. So if we are trying to store A is equal to 8 tick binary 0010 followed by 1000. This is 8 bit. So in location 1, how many bits, what are the bits get stored in location? These are the bits which get stored. So it will be 1000. So in location 1, will have the bits 1000, and in location 2, we will have 0010. So like this, in a packed array, the bits get stored if we mention like this. And if we want to access location 1, then we will write output is equal to A of 0. Please wait a minute. So if we want to access location 1, then we will write output is equal to A of 0. Then the output value will be equal to 1000. And if we want to access this second location, that is which is containing 0010 0010, then we will write output is equal to A of 1. Then our output will be equal to 0010. And if we want to access the second bit, sorry, this is first bit, second bit, third bit in first location, then the syntax will be equal to, so if we want to access third bit in first location, then our syntax is location, that is first location followed by third bit, which will be equal to 0. So this is how we will store the numbers in the packed arrays, and we will access the numbers from the packed arrays. So see, if we don't use a packed array, we will directly use a byte and we'll declare A, and we'll store the same number. A is equal to 0010 followed by 1000, and here we are getting output initially 1000. From here, if we want to access 1000, then we will take a for loop and we will write the code accordingly for accessing this particular number 1000. If we want to access this particular digit, then again we will use a for loop. Whereas in case of packed arrays, our job is very easy. We can slice the array easily, very easily. So this is how we will we can store the digits in the packed arrays, and we can slice the numbers easily with the help of packed arrays. So this concept of packed arrays is clear, right? Can anyone respond? Can we move forward? Yeah, guys. Can anyone respond? Is this clear?
Yeah, I saw.
Yeah. So this is the concept of packed arrays, and let's see with the help of coding how we are achieving this. And We cannot use packed arrays of type byte and int. We cannot use. We will get errors when we try to use packed arrays of type byte and int. We can use packed arrays of type bit and logic. So yeah, this is about packed arrays. So I've taken a packed array of 8-bit a underscore packed. Now let me take uh, our PPT example. Bit 1 down to 0, 3 down to 0. Bit 1 down to 0, 3 down to 0, a underscore packed underscore 2. So this is a 2D array. Now I'll assign this a underscore packed, which is equal to a tick binary. Uh, the same number 0010 1300. 0010 1300. And I will display this array. So at the output, you can see the value of array is 0010 followed by 1300. So 1300 is stored in one location and 0010 is stored in another location. So if we want to access 0010, then we can simply write. Wait a minute. Let me end the simulation. So I will take bit 7-bit 7 down to 0, output underscore b underscore packed. is equal to a underscore, okay, sorry, underscore 2 of 1. I'll take it a only. So I'm trying to access the first location, that is 0010. Let's see what we are getting. Let me run, compile it. Yeah, simulate. So the wait a minute. I haven't displayed. Oh, sorry. Percentage B, comma a output underscore a underscore packed. Let me compare it again and simulate it. So at the transcript, we can see we are getting 0010. Here four zeros are getting appended. I have taken 8-bit, so four zeros are getting appended, and the last four zeros, four digits are 0010. Since I have taken the output of width 8-bit, so four zeros are being appended and followed by the number. If I take 4-bit output, then I will get only 0010. So this is how I can access a particular location from the packed array. So this is clear. Is this clear?